Okay, I vote go ahead and get started. Okay, great. So I'm Dr. Anderson. Because of everything that's going on right now, we've decided to move our workshops online. So that's why I was wondering how many of y'all aren't from Georgia State, because our workshops are always open to everyone, but since they're housed on campus, usually we get the majority of people from GSU. So my goal tonight is to work through R Studio, which is a package that you overlay onto R. It's a program. And not surprising, you probably know this already, R is one of the most popular, fastest growing statistical analysis packages right now. And the thing that makes it exceptionally appealing, beyond the fact that it's really powerful, is it's absolutely free and open source. So I just want to set some kind of general base understandings. I have the assumption that you have never used R, or you have very little R knowledge. I do assume, however, that you have at least a little bit of statistical knowledge. So if there's any point tonight where the statistics don't quite make sense to you, or they aren't clear, feel free to reach out to me via email to really talk about those a bit more, or maybe put a question in the chat and we can kind of crowdsource them. But my goal tonight is really to get you to know just a little bit enough about R that you're comfortable looking at things on your own. So before we get into R, I want to give a little bit of background on the department that I'm in and the programs we're running at State, and then we'll jump into R for the remaining probably hour and 45 minutes. Maybe. Maybe on my sleeping screen. Okay. So I'm on a team called Research Data Services. There are a handful of us that are on this team. We're housed in the library, which makes us pretty unique here at Georgia State. Our leader is Dr. Swigart Hobaugh. She's a qualitative methodologist. So she teaches workshops on in vivo, and she's also well-versed in data visualization and some quantitative methodology. She teaches a phenomenal series on in vivo, which is a program that's used to study qualitative data. If you're interested in that, please check it out. And then we have Joel Gligowski and Kelsey Jordan. They're both data visualization folks. Joel and Kelsey are a really great team, and they have really different backgrounds. So I always really like hearing their perspective. Joel has a background largely in business, and Kelsey's background is more in the physical sciences. So they share a lot of common ground with data visualization, but they have a lot of ideas of how to expand it across different groups. Then there's myself. I'm a quantitative methodologist. I am classically trained as a sociologist. My PhD is from the University of Nebraska in the sociology department. And I'm really interested in survey research methodology, quantitative methods, mixed methods, survey design, things like that. And we have Jeremy Walker and George Usmanov. I want to introduce them both figuratively and literally. Jeremy Walker and George are both here to help moderate some questions that you may have that come up in the chat. So Jeremy just posted something about the link to the code information. George says, hey. So Jeremy is one of our really new faculty members. He recently moved overseas to join us at Georgia State, and he does a Python, which is phenomenal, and does a lot of coding in R. His background's in data science. And then George is my GRA. He's a really phenomenal graduate student in the sociology department. And he works in SPSS and R and a little bit in Stata, but R is really his home language, and he's interested in a lot of network analysis. So if you have questions that are quantitative in nature, you can reach out to one of the three of us. Something that makes all of the other faculty members, except for me, unique is they're also sub-librarians. So Dr. Swigart Hobaugh is the sociology subject area librarian. Joel does nursing. Kelsey does physical sciences. I don't have an area. And Jeremy does ESL and another department I can't remember, sorry. So we have general information, and applied linguistics, thank you. We have general information link that I sent to Jeremy. Hopefully he can share that. More information on our workshops. So the workshops are open to the general public. Everyone and anyone is welcome to come to those, and we're now recording our workshops for the rest of the semester. So if there's one that you missed and you want to watch it, a link will be put up in the chat where you can go and see the video. If you're a Georgia State person, we also do individual and group consultations, and you just have to email us. So this is like the lion's share of our job. Last year, I did a little over 750 individual consultations. So we get tons and tons of questions, and we really love working with people. And we have stopped doing our drop-in hours, but our drop-in hours are like office hours where you can come and ask questions, and we can work with people on the fly. And we hold those in the library every week. So that's Research Data Services. If you have any questions, please put them in the chat, and I'm sure that one of my colleagues can answer them for you. To y'all about is a data certification. At Georgia State, we started this data certification that if you come to 5 different workshops or watch 5 workshops, you get a data certification. It is completely free and it's open to everyone in the community. So if you are at, I think somebody said the University of Puerto Rico, you can watch 5 of these, participate in 5 of these, and get a data certificate. And we'll mail it to you at the end of the semester. And by mail, I mean email. And how you get this is you check in, and we'll give you the link at the end of the workshop to be able to check in for your attendance. Even if you were not planning to get the data certification, please make sure you check in, because that's how we keep records of how many people come to our workshops. So in the future, we can decide, do we add more workshops or take away workshops? Any questions about the data certification? Last thing I'll talk with y'all about before we get into the fun stuff, which is GRIP. So GRIP is a program that I started at Georgia State University. It is only for graduate students at Georgia State. It's a 2-week program. It's an intensive, it's 70 hours training, and it takes you through research methodology, statistics, and by the time you leave GRIP, you have a conference-ready presentation. Last year, all the people decided to do a logistic regression analysis. So the purpose of this is to really help pull together scholars from different disciplines and allow people to learn a ton about coding and research. And I'm like kind of styling this after StatsCamp and ICPSR, but more project-based. So if you're a current graduate student and you're interested in this, the applications are due by the end of June. Please make a thorough application. Last year I had a little over 250 applications for 20 spots. So it's competitive. And this is the only program RDS offers to people that costs anything. So it costs $40 to be in the program, and that covers like your notebook, your printouts, a jump drive, and snacks, because we learned that people need snacks when they're learning. So do y'all have any questions, comments, or rude remarks about RDS, Georgia State Library, the certificate, or GRIP? Okay, so GRIP is campus. So how GRIP works is you attend, GRIP link is in the top comment that he just posted. GRIP is on campus, and it is 2 weeks prior to the prior to the fall semester starting. And how you get the certificate is you attend 5 or more different workshops in the same semester. So this counts as 1. And you can either attend or watch other certificates. And then what we'll do is we'll email you the certificate. I think it's April 20th. So the deadline's coming up pretty soon. So if you want to do the certificate, make sure you get that knocked out. Okay, so let's get more open. Can you see what's on my screen? Okay, like, can you see that what I typed in there? I want to make sure that my screen's not too small. Phenomenal. Look at y'all participating. I love it. Okay, so what I'm going to do is I'm going to go and I'm going to put some code in here so that you can see what things look like. So this this program is called RStudio. You can download it for free. And if you go to that website I gave y'all at the very beginning of the workshop, it has a link to download RStudio. So let me pull up this website. So this is the site I actually go to. And if you go to R1 workshop materials, this will have information up here about how to get R, and then there's a handout if you want to look at that. Some people are paper people, they like to have something to look at. Click on that handout. But what I'm going to pull is all of this code. So this is the code that we're going to use for the workshop. And you'll see very quickly why I didn't want you to type this in if you're following along at home. I just want you to have it and copy and paste it over. I'm just going to copy this. And then up here, I'm going to paste it into the script window. So this is script. Great. So y'all are going to have to go through this. I'm very used to teaching in person, so I'm going to ask a lot of questions. I think that's how we learn best. So what colors do you see the code is produced in? What are the different colors that you see on the screen? Okay, there's tons of green, there's blue, there's black. Does anybody notice anything distinct about the green lines? What do they all start with? Great. So based on your generation, the hashtag or the pound sign is going to start this line. Every line that starts with a hashtag is going to be an annotation. And the annotations are going to be really important for you as a researcher to know what you've done in that section. So you're going to notice that I'm a firm believer in annotations. I use them in my own work. I definitely use them while teaching. And anytime a line of code with a hashtag, RStudio will not run it. It will say, oh, this is a that the researcher put in. So please make sure that you use these. So at the top here, I've explained how I put code together. I really like organization. I think that coding is difficult to learn, and I code in 7 programs, so I always try to give myself a lot of notes, give myself a lot of help. So I'm going to put big headers in before we cover a new topic, and this is not for the workshop. It's actually when you go to work on this on your own and when you go to run this code on your own, so you're not sitting there being like, what did she talk about again? I don't remember what the section does. So there's going to be tons and tons of headers and annotations. The next thing that I do is whenever I introduce new code, I'm going to immediately follow it with an annotation explaining it. The reason for this is when I started learning code, I really struggled to understand what is a database, what is code, what is a variable name. So I'm hoping that my annotation system will really help you with that, and I'll show you a bit more when we get to it. And then this rest of it is talking about what I mentioned about if you start a line of code with a hashtag or a pound sign, it'll be ignored by R. So the first thing I want to talk about is how to run code. So if you've never used a statistical package before, code is the general name for the commands that you type in to produce output. So in R, it's called a script file. In SPSS, it's called a syntax file. In Stata, it's called a do file. In SAS, it's called the editor. But here we're going to do scripts, but code is the universal language for commands that you're typing in for you to understand what's going on. So there's 2 ways that you can run code. The first one is you can highlight the code and then hit this run button at the top. So this run button will run the current line or whatever you have selected. So I can either highlight it and hit run, or if I wanted to, let's say line 30 had code on it, I could click on line 30 and then hit run. It is the same thing. So you can do that, or you can highlight the code that you want to run, hold down the control button and hit enter. So I'm going to say that a couple times because I know you can't see me doing this. You'll hold down the control button and hit enter, and that will run either the line of code that you're on or the block of code you have selected. So hold down control and hit enter. It is not control then enter, it's hold down control and hit enter. Okay. So that's the kind of the basics of the first 30 lines of code. Really, really simple on that front. So how to add packages. Packages are really important for R. RStudio is a base program, and then you add packages onto R, and it helps do different functions. So if you have a package called, this one I'm going to upload is called RCommander. RCommander actually lets you point and click through R. Another package that's really, really popular is a series of packages called Tidyverse. And then another really popular one is ggplot for plotting. So if you want to install packages, the code is relatively simple. It's install.packages, and then in quotes, you put in the name of the package that you want to install. So how I would run this is I would highlight it or click at the beginning, hold down Control and hit Enter. Well, once you install a package onto your RStudio, it's there. And because I use RCommander, it's already going to be in the system for me. If you would, make sure that you're watching where I'm clicking. So another way that you can install packages is go to Tools at the top, and the first option under Tools is Install Packages. And you'll see that this window comes up. So one of the packages I talked about earlier was ggplot. So I'm just going to type in ggplot, and do you see how it's automatically pulling different packages with that name? So let's say I wanted to download ggplot2. I would just click on it and I could hit install. The truth is most of us use tons of different packages. So if you want to do social network analysis, there's certain packages for that. There's structural equation modeling packages. There's hierarchical linear modeling packages. There's tons of different packages that you may want. So you can either install them one by one, or you can put the name of them in and separate them with a space or a comma. So if there's 4 or 5 packages that you need to download, you can put the names of each of them in here. So I'm not going to hit install. And the reason for this is when you hit install, it installs it. And it runs through a lot of screens to get everything loaded. As a general rule now, me, Jeremy, and George, if you do this differently, I just say okay to whatever R wants. So if R is like, do you want to install this package? Yes. Is there other packages you need to run that package? Do I download it? Yes. Just generally say yes to R when you're installing packages, and it'll work well for you. So I'm going to hit cancel. The next thing that you do, the two-step process. The first one is install the package. Then the second one is pull the package up. And you'll notice that this happens a lot in R. There's a kind of a make a promise of something or down and then open. So the first line, install packages, is how you install the package. Code library will open it. So I hold down Control and hit Enter. Oh, don't make me alone. Let me run this install packages. Okay, we're gonna say no because it wants to restart R. Let me give it just a minute. Okay, it wants me to restart R. Normally I would, but I don't want the program to crash. So I will, if we have time at the end, I'll try to rerun this to see if it'll work, but I'm just worried that R will crash on me because my computer's having issues, not because of R. Okay. So the next thing that I want to show y'all how to do is pull or call in data. So different people call this different things. Ultimately, it's opening up a database. The truth is there are tons of great databases already built into R. So if you want to practice with R, if you want to get better at R, what most people out there, like on Reddit especially, what they do is they say, open this data set, and then here's code for you. So when you're learning R, I strongly suggest that you use some of those tutorials, practice on the data sets that are already built into R, and then work with your own data. I know that most of us don't care about other people's data. We just want to work with our own data. We have our own studies we're trying to do. And 9 times out of 10 do that. But with R, I promise it's worth investing the time of using other people's data first. So if you want to view all the databases built into R, this is the code. It's data, open parentheses, close parentheses. And what this means is I want to see all of the databases that are built in. So I'm going to hit Control Enter. And you'll notice that it opens up a new tab. and it says, and then in here, there are tons and tons of data sets that you can use for your analysis. So I'm just going to scroll through these kind of slow so you can see the different things that are existing in R already. Now, I'm assuming that at least a couple of y'all are like myself and Jeremy and George, and you like working with bigger data. And I don't mean big data air quotes. I mean like, you know, a couple thousand people, a couple hundred variables. So what you'll do is you'll practice with these, but know that there's not going to be tons of data points. So a lot of these have 10 variables and 30 people or 30 respondents just to get you enough practice to see how the different factors work. I know that R has made a concerted effort to try to put different types of data in here. So there's data on growth, there's data on chicken weight, there's data on state data, there's census data, there's tons and tons of different for you to look at and give yourself kind of an understanding of these different factors. So this is a nice little build-in for you to look at. Okay, so now that we've looked at the data, we went through here and we were like, oh, I think that this database looks really good. This Ginsberg data on depression. So as somebody who studies mental health, I'm really interested in people's depression. So I'm going to say, I'm going to look at this Ginsberg data. So I'm going to go back to my script file and it will let me call in the data. Now, spoiler alert, I had already picked a database. So you'll see here on line 71 through 81, here's the information for all of the different variables in this database. So Ginsberg data has 82 rows and 6 columns. So it has 82 people across 6 variables. And these are the different variables that are measured in the database. The truth is the topic of the variables doesn't really matter because I'm trying to show you how to use the program. But if you're anything like me, you want to know what the data points are measuring. So that's why this is in here. So how you call in the data is you use this code data and then Ginsberg. You'll notice that it's data, and the difference between the last code and this code is simply just the database name in the middle. So do y'all see how this says data Ginsberg, and then the very next line of code says data and then database name? This is how I annotate code. Anything that is different from the line of code and the annotation is what you replace. So here, the only thing that's different is where it says database name. So you would replace that with a database name. So I'm going to run this line, data Ginsberg. So I'm going to highlight the line of code, hold down Control, and enter. And you're going to notice down here in the console box, it just says data Ginsberg. Now, R is really good at telling you if you did something wrong. It'll pop up an error message and all of that. And then the other place that you'll notice something populated is over here in the global environment. So in the global environment, this is the name of the database, and then there's a promise right here. So the promise is going to say, I'm holding a spot for, Erin, I'm going to cover that in just a second of how to pull in data from Stata in Excel, I promise. So the Ginsberg data step allows you to hold a spot for the data. But what we need to do from here is actually open the data. So it's a two-step process, putting a promise in the global environment with the data function, and then using force, and force opens the data. So force and then the database name will open up the database. So I'm going to highlight this line, and if you'll notice, if you'll look over here in the global environment in the top right corner, right now it says promise, and then when I hit Control, and you see it says 82 OBS of 6. I'm going to just drag this over a little bit so y'all can see it. And if I click this blue arrow, it currently points to the right. And if I click on this blue arrow, it then drops down. What are these different things right here? What do you think these are? The simplicity, fatal, depression, ADJ simp, ADJ fatal, ADJ depressed. What do you think those things are right there? Exactly, Katie. Thank you so much. They're variable names. And then beside that, you see it says NUM. So NUM means it's a numeric variable. So the values of the variable are numeric. And immediately following that, you see that there's specific values that are populating. Those specific values are the respondents' answers. So if it's respondents, but if it was companies, it'd be different companies. So this gives you a nice visualization to see, did the data open correctly? So that's what's up here in the global environment. Then down here in the console, we see an 82. And what I'm going to do is I'm going to, at the very last line, I'm going to just a little bit to the top, and you'll see that it gives us the database. So simplicity, fatalism, depression, ADJ simp, ADJ fatal, ADJ depressed, which is the same variables as right here in the global environment in the top right corner. You'll also notice that this 0.93 is 0.0929. So we know 0.099 rounded is 0.93. And we can for each of those and kind of work our way down. So this is nice. It gives you the information. So that's how you open up a database. So into the global environment, and I'm going to click this little arrow just to clean it up a little bit, so you don't have as much going on your screen, but you can leave it down if you would like. So that's how you open databases that are built into R. And when you do that, the information populates over here in the global environment and down here. Now, if we've ever met, you know that I'm a little skeptical when it comes to data running well. Like, I want to make sure that everything seems right. So if I want to run basic statistics, summary, and this is because most basic statistics are called summary statistics. So summary Ginsburg will give us the summary statistics on variables in the database Ginsburg. And you'll notice immediately following, again, we have this hashtag with the annotation, summary, and then inside the parentheses, it says database name. So what you would replace with when you do this on your own is it would be summary, because that's the same, and then Ginsburg would be changed to your database name. So I'm going to run line 109 with control, and I'm going to pull this up a little bit so y'all can see it a little bit better. You'll see here that these summary statistics are the minimum, the first quartile, which is the 25th percentile, median, which is the 50th percentile, the mean, which is the mathematical average, the third quartile, which is the 75th percentile, and the maximum, which is the 100th percentile or the highest value. So you'll see that this is reported for every variable, and the order goes across and then down. So variable 1, 2, 3, 4, 5, and 6. So if you all have any questions about how to open data that is built into R, and right after this, I'm going to cover how to pull in data from Stata and SPSS and SAS and Excel and all of that. But I want to give y'all a minute to ask questions. So do y'all have any questions? Cool. All right. So this next section that we're going to, if something comes up, it's fine. Just ask it. Nobody cares. The next section I want to walk y'all through is databases not in R. So this isn't going to have a lot of code for us to like run and see how it produces, because it'll to be contingent on your own data. So what I've done here is I've used data that are saved on my computer as examples, and then you'll replace it for your own. So this is the order that I covered these. SPSS, SAS, both an export file and a B7 DAT file, a Minitab file, a Stata file, and an Excel file. The reason I chose these 5 is because they're really common database forms that people want to pull into R. If you have other database forms that you want to pull into R, email me or Jeremy or George, and we can help you out with that, okay? So we're going to go in this order, and I'm going to walk you through these relatively quickly, but please, please, please ask questions in the chat if you have questions. So for an SPSS file, I have done all of these with an actual code example followed by a code with placeholders. So the actual code is like this. The name that you want to call the database in R. So I practiced all of these with the General Social Survey from 2016. So I'm calling the database GSS 2016. Now, a couple of tips. You don't want the database name to be really long because you're going to have to type it over and over in R. So I might even shorten this if I was doing this research on my own to GSS 16. I realize it's just moving 2 placeholders out, but when you write a couple thousand lines of code, it makes a difference. So this is the name that you want the database to be in R. Then the arrow and read SPSS. Then you follow that by the path where it is saved. So on my C drive, under users, named RADA, in the desktop, there's a file called GSS 2016 _1_ and SAV. So a .sav file is an SPSS file. So if you get a data file from a mentor or a colleague and you don't know what kind of file it actually is, this is a nice way you can kind of scroll through this script file and be like, oh, it's an SAV, so it's an SPSS file. But you put the path name in quote, comma, and then you say row names are false because we know in SPSS, the variable information is housed separately than the data. And then strings as factors is true. So this will make everything that was a string variable or a word stay a word. It won't convert it to a number. And then do you want everything to go to lowercase? And I'm going to say false. So the reason for this is in SPSS, capitalization matters. So you don't want everything to go lowercase. I will tell y'all that 9 times out of 10, all y'all have to do is replace this. All you have to do is replace the path file and then whatever you want to call the database. The rest of it is going to stay the same. Now, right below that, you'll see code with placeholders. I have GSS 2016 here, and then it says database name. And then it says read SPSS, and that's the same in each code. And then this is different. Y'all see that? That's a C drive, and then this says path name where the data is saved. Anything that's different from the original code and the code with placeholders is what you edit. Everything else you can just copy and paste. So that's for SPSS. Following that, I have 2 SAS files. I have a SAS export file, and all you have to do for the SAS export file is name the database, type in read export, and then put a path name in. It is simple, simple, simple. So the SAS export file is really, really easy. For the SAS BD7 DAT file, it's a little bit more, stick with me. So database name, just like all of them so far, and then read SAS, the path file, strings as factors will be true. And just as a reminder, that means if it was a word in the SAS file, you want it to be a word in the R file. And then row names is false. And that's going to say the first line of data is not the row names. The first line of data is data. So it is very important. And if you are a SAS user like myself, please make a note, either mentally or literally, that the 2 different SAS files have different ways that you pull them in. So that's SAS. The next is Minitab. Minitab is very simple, like a SAS, original SAS file. You change the database name as data frame, and then you have a read function in. And so what you would replace again is where the file. So how the code with placeholders works is if you look at the actual code example, it'll say, here's the code that I literally used to get the data into R. But the code with placeholders takes the original code, and anything that you would change for your own code is different. So see here, it says GSS 2016, but the code with placeholder says database name. So you would replace GSS 16 with whatever you want the database to be called in R. And then as data frame, read MTP is the same for both of these, so you wouldn't change that. But this is different. C users, which is the path of where the file is saved, and then you'll change that with the path where the data file is saved. Okay, so that's for Minitab. Then Stata. Stata is my home language. Stata is my favorite language, so I always, when I talk about pulling in data files. This is the actual code example. So just like before, you name the database with an arrow, then it reads Stata. You will change the path name, and then convert dates equals true. If you are a researcher who does any type of time series analysis or timestamp analysis, longitudinal panel studies, anything like that, please, please, please make sure that this is set to true, because Stata treats dates differently than R. So if you don't say convert dates equals true, it will make the dates numbers. So you want to make sure that you are very conscious of this, especially if you do longitudinal research. Then strings as factors is true, just like before. This means if something was a word, keep it a word. And then row names is false, which means the first line of data is data, not variable names. And again, you can look at the code with placeholders. Okay. Krispy Kremed, which means you kind of zoned out, glazed out. I need you to come back to me because Excel's a little bit tricky. So if you could kind of really pay attention to this Excel, because this is the thing that I get tons of emails on all the time. How do I pull my data in from Excel? Okay. All of these things in Excel, you very well may. So all of the 1 through 4s, you probably won't change much other than the name of the database and the where the file is. This you'll likely change different factors. So let's walk through it kind of slow. This again is your database name. That's the same. Then you say read XL and you put the data file name in. So this should look relatively similar to what we did before. Here's where things get a little bit tricky, okay? Row names should be equal to false if the first line in your Excel file is data. If the first line in your Excel file is the name of the variables, that should say true. Then header equals true will pull in those names that you put in the first line. Where it then says, let me keep highlighting, I think that might be helping. NA, a blank. So what that's saying is NA equals a quote space quote, which means that there is nothing in the cell. So in Excel, when we don't have a datum point, most of us leave it blank. Well, R needs to know, what does the blank mean? So NA is the code for missing in R. So NA means it's blank. So if a cell is blank, then convert it from a blank to an NA. This is really important. So I just want to say it again so it's really, really clear. In Excel, if you have missing data, you can just leave it blank. When you pull it into R, you have to identify the blank as missing data. So that NA that I have highlighted with the quote marks is saying, make the cell missing, which is NA, if the cell, oops, didn't mean to do that. If the cell has nothing in it. And the reason that we know it's nothing in it is mark with a blank and then another quote mark. So that'll say, If there's nothing there, coded as missing. Then sheet tells you which sheet do I pull from on your Excel file. So let's say that you are studying 5 different corporations or 5 different groups of people, and you have one group of people on sheet 1, one group of people on sheet 2, and another group of people on sheet 3. If you want to pull the data from sheet 1, then you say make the sheet equal to sheet 1. If you've changed the name of sheet 1 to Atlanta data, then you would replace where this says sheet 1 to Atlanta. So ultimately, what you want it to say is equal to the name of the sheet in Excel that you're using. And then this last section, strings as factors is true, is going to be saying anything that's a word, keep it as a word. So if something says Rada Anderson, which is my name. So if we have a column that's respondent's name and it says Rada Anderson, you want it to stay as Rada Anderson in the database. So the reason I went through this a little bit more painstakingly slow is this is the thing that most people make the edits on. If you want to pull multiple sheets, then you say you rewrite this function for the different sheets. So let's say you want to pull 3 sheets, you would copy and paste this, and you would say sheet 1 is going to be called Atlanta, sheet 2 is going to be called Baltimore, and sheet 3 is going to be called Kansas City. So you can make the different databases and pull multiple sheets. You also can have multiple databases open at one time in R, which we're going to do a little bit today, but we're really going to dive in deep for R2. You'll notice that down here on the code, and remember this is on that website, more information on things that you should change so that if you want to really dive into Excel, I try to put as many directions in there as I can. Okay. Do y'all have any questions about opening databases that are not in R? So Excel. So the question is, can I pull multiple Excel sheets from different files and compile them into one database? Would that be possible given all the sheets are structured the same? Yes. So what you can do is you'll open the data files and then you can run them synchronously with each other. The next question from Matthew is, can you repeat the conditions for true and false for row names in Excel? Oh, absolutely. Thanks for asking the question. So let's go back to this here. Is this what you're talking about, Matthew, on 185 and 186? All right. So do you see here where it says row names are false? So this is if you have row names built in instead of the column names, this would be true. I don't actually know anybody who does that. Almost everybody I know uses the first line of the row 1 as the names of the variables. So if you do that, that's what this header is. So if the first line 1 in Excel are variable names, not datum points, this should be true. If the first line is datum points, this should be false. And then strings as factors right here is, do I want to keep words? So if you have somebody's email address, do you want to keep that as a word or do you want to convert that to a numeric function? Does that answer your question, Matt? Sorry, Matthew. Cool. Okay, so Stephen, give the sheet and must use the same Excel name when calling in the sheets in the code. Is this different from just saving the file as a particular name? Okay, so I think I understand your question. I think what you're saying is, let's say you have the Excel file saved as Atlanta, but the first sheet is just called sheet 1. If you're doing that, then you have to type in sheet 1 here. Now, if the Excel file is called Atlanta and that sheet is called Atlanta, then this where it says sheet 1 would be Atlanta. But you have to put in which sheet you want to pull from on Excel. Does that make sense? Does that actually make sense? That seems like a very nice answer. Like, I just want to make sure I say, okay, thank you when I don't understand what someone said, but they answered me. So this right here is going to be the path of where the data was saved. So if you have it called Atlanta, it would be here, and then whatever that sheet is called. Okay, cool. Any other questions about pulling data in from other sources?
Rita, could you hear me?
Yeah.
There were a couple questions earlier in the chat on a higher level that George and I responded to, but maybe you could give some really good feedback as well. And that is, from a high level, how does R compare to like SAS, Stata, SPSS, Python, with respect to why you would use different tools or which ones might be easier to learn in different contexts?
Oh, okay. That's a common and good question to ask. So I code in a lot of different languages. And so most people code in maybe one or two. And due to some training and some research opportunities, I code in 7 programs. And I think that R is one of the better ones. So let me kind of explain why. The first reason that I really like R is it's open source. So I don't know if you've ever tried to buy a statistical package. They're very expensive. And usually they come out with a new version every year, every couple of years. And it's not uncommon to have to pay $400, $500, $700 for a copy of it. I really struggle with gatekeeping. So gatekeeping is when we put a price tag on things, requirements on things that don't make them accessible. So I really dislike some of my favorite packages, some of my favorite programs because of that. Another reason to really learn R is it's very powerful. So this morning I had someone email me in a frantic about their dissertation, and they couldn't get the analysis to run in Stata. And while Stata is my favorite program, it's the program I use for almost all of my own research, it's not as powerful as R. So they let the analysis run in Stata and it crashed. But they were able to run it in R in about 15 minutes. So that's something that's really nice. But the truth is, if I was you and you were me, the advice that I got that was the best was advice that I got when I was an undergrad at Valdosta State. And my mentor told me, look at the people you want to be like and find out which programs they use. Ask them which programs they wish they knew. Those are the programs to learn. So I learned SPSS. That's the program that I learned in school. But the researchers that I wanted to work with worked in Stata. So then I learned Stata. And then I wanted to be on a grant that used SAS. So then I learned SAS. And then I wanted to do analysis that was an M+. So I learned M+. So the thing that I've always learned my packages was out of necessity. But being multilingual really helps you understand statistics at a deep level. And the hardest thing that you'll ever learn is how to code the first time. After that, it becomes really intuitive. But to take it to a higher level and not so personal, if you want to know which package or program to learn, look at what the jobs are that you think you want long-term and learn those. The truth is, basically everyone's moving to R and Python. They're really powerful. There's some things that I don't really like R for. I think the tables are relatively ugly, and I wish they gave me more information sometimes, and a little bit later. But think about your purpose and go from there. You know what I mean? So like if you're a public health scholar or a demographer, you have no business really using SPSS because it's not built for that. But if you want to be somebody who does data science like Jeremy, I would learn Python and R because they have the power to do that. Does that make sense? That was really long-winded. I'm sorry. Other questions, or was that it?
One more question came in. Would it be easier to convert Excel file to a CSV?
Yeah. I mean, yeah, if you just convert it to a CSV, then it pulls in easier, but you can use either one. Cool. All right, so let's talk about more databases. So This is how you change databases. Y'all remember earlier we opened up the Ginsberg data. It has 82 variables of 6 observations. Well, I want to look at this database called states. So remember, data promises it. So I'm going to hit Control Enter, and it pulls it over here into the promise function. Then I'm going to run force, and that opens up the data. So we have 51 observations of 7 variables. We did this earlier, but I just want to show you how easy it is to open multiple databases at once. So if you're a SAS user or you have a history of, you've already been doing this, but if you're an SPSS user or a Stata user or an Excel user, this is a pretty new fancy thing that you can do. Earlier, we ran this code right here, summary states, and that gives you summary statistics. So I'm going to hit Control Enter. Just like before, it gives us the summary statistics of all of the variables in the database. So their region, their these variables I don't know, these other variables I don't know, all of the variables. So that's how you open multiple databases. And you'll notice here that you don't have to clear out the old data. You can have tons of databases open at one time. So this is a really big push for R. If you are somebody who likes to work seamlessly between databases or look at multiple databases at once, this is really nice. Then this view function right here will allow you to view the data. So instead of forcing it open and looking at it, let's say you already have the data open and you just want to look at it, click view, and it opens it up in a new window. Y'all see how this state opened up? And it gives us our data view. Now, something that's nice is you can click and you can sort in here. So if you want to say, okay, I want it to go from highest to lowest percent or lowest to highest percent, and I can repeat that for each of these. So it's a way to be able to quickly work through your datum points, and you can see that they're all here. That's how to just change databases. So now moving forward, we have the Ginsberg database we can work in, and we have the states database that we can work in. So now I want to go into running descriptive statistics. So earlier, I showed y'all how to run these summary statistics, but I want to put them together code so that if you want to see them together. I really like when I learn a new package for our new program for all of the code to be together so that when I'm confused, I can just search through it and find what I need. So summary Ginsberg will run the summary statistics for all of Ginsberg, hitting Control and then Enter, which we've already seen before. And then summary states will run the summary statistics for the entire database of states. So you probably are saying to yourself, yes, I don't want all of the summary statistics. I want summary statistics for a single variable. And this is how you do that. Summary database name, $, and then the variable name. So this is saying I want the summary statistics from the database Ginsberg variable depression. So summary statistics on the database Ginsberg variable depression. I'm going to highlight this and run it. And you'll notice down here in the output, it only contains the summary statistics for the variable depression. So if I want to run the summary statistics from the database states on the variable population, this is the code. So summary, database name, variable name. Highlight it, hold down Control, and hit Enter. So I'm doing this for multiple reasons. I want you to know how to run a specific variable's descriptive statistics, but I also want you to see that I didn't have to do anything except for identify a new database in the summary function. I don't have to close out the other database. I can seamlessly between the two databases very, very simply. So that's how you run specific variables in the database. I think one of y'all asked earlier, how do I run like a standard deviation or a different statistic? So I want to walk through that. Now I want to remind you that I'm a sociologist, so I'm going to be slanted towards the social science statistics, So if you have questions about other individual statistics, pop them in the chat, and I'm sure Jeremy or George can find you some code. So we're not going to spend a lot of time on this. I just want to walk through them so you can see. If you want to run the mean, which is the mathematical average, you say mean Ginzburg depression. Now remember, whenever you do the database name, then the $, and a variable name, that's saying I want the mean from the database Ginzburg on the variable depression. So I'm going to highlight this and hold enter, and you'll see that it produces the value for me down here. So that's for the mean. This is for the median. So mean, the code for mean is mean, the code for median is median. So this will give us our median. And we see here that our mean and our median are pretty close, which tells us that our data is probably not skewed. Or if it is skewed, it's not skewed a whole lot because they're really close in value here. If for some reason you want to run just the minimum, you can do the min function. If you want the maximum, the code is maximum. So the minimum will produce the minimum value, which is 0.469, and the maximum will produce the maximum value, which is 2.24. And then this is the range. If you would please, to the value that's outputted here. You'll see the code is range, database Ginzburg, variable depression. So I'm going to run line 264. And do you see how it gives me the two values of the range here? So it does not calculate the difference. It gives you the mean, the minimum and the maximum value. So that's nice. Instead of giving you a numerical range, it gives you the limits of the range. Then if you want quantiles, the code is quantile, database name, variable name. So highlight this, control enter, and that gives us the minimum, the 25th percentile, which is the Q1, the 50th percentile, or the median, the 75th percentile, which is Q3, and the 100th percentile, which is the maximum. Now, you can also identify which one of the quartiles you want. So this is a num summary function. This works with R Commander. So please, if you're like making notes either literally or figuratively, this code is with R Commander. Do y'all see how much longer this code is? So RStudio has largely developed with the program's very simple code, mean, range, min, max. But if you want more nuanced things like a specific percentile, the code becomes much longer. So num summary is the code. Then the database name, in the quote you put the variable name, drop is equal, and then the statistics that you want to run are quantiles, and then the quantiles that you want are the cutoff points of 0, 0.25, 0.5, 0.75, and 1. So 0.25 is the 25th percentile, 0.5 is your 50th percentile, 0.75 is the 75th percentile, and then 1 is the maximum value. I'm going to highlight this and run it. And y'all see down here how these values are the same as the last output that we did. So let's say that you don't care about the 50th percentile, but you're interested in the 90th percentile. So I'm on line 272, and I'm going to change this 0.75 to a 0.9. So I'm going to change the 0.75 to a 0.9, and I'm going to run it. And now I have the 90th percentile in my output. Put this in here on purpose. This is the first time that we see multiple codes that produce the same output. So this 268 was the exact same output as 272, but 268 wasn't very flexible. We could only use quartiles that have already been prescribed. But here, because we're using this lengthier and identifying the quantiles, we can change them if we would like. So if some of us do research and we're really interested in outliers, so you may want to know about the 0.05 and the 0.95. So what identifies the outliers? The extreme 5% on each end. So something that's nice about this is you can manipulate it, but as you can see, this code's a lot more complex. Now, if you are a person who would have learned R just a couple years ago, most of the code looked very similar to this because RStudio has exploded and has become much more advanced in the last couple of years. Okay, so that's for quartiles. The next one is for variance. Variance is simply VAR. So remember, variance is the standardized form of the standard deviation, and that tells us how much variation within the database, Ginzburg variable depression. And then if you want the standard deviation, one of y'all asked about this recently in the chat earlier.
Okay, great. What happened to my connection?
Okay, so I'm going to run deviation. So this is how you get into now more advanced statistics that you may want, such as the mean, the coefficient of variation, skewness, and kurtosis, are going to have more complicated code for you to write. So very the statistics already are set up, but the more advanced statistics do more advanced coding. So let me try to mute that microphone. Jeremy here. Okay, I'm just going to keep going, but Jeremy, can you try to mute them? All right. Are going to be functions with the base code out of. So this is saying run a num summary on the database Ginzburg variable, cool, thanks, depression, and then drop it. So keep the variable in there, even if it's missing, so that you can run that analysis. And then statistics are going to be classified as the standard error of the mean. So look, these lines of code right here from 284 to 296, the only thing that's different is what's in this quote mark. Do y'all see that? This is standard error. This is coefficient of variation. This is skewness, and this is kurtosis. While this code is a bit more complicated, all you do is you edit what it works. Does that make sense? So I'm going to run the num summary for the standard error of the mean, and it gives mean output. Something that's nice with the num summary is whenever you run this specific analysis, it will tell you what you ran. So I'm down here in the console and see where it says SE mean. That's saying, okay, you asked for standard error of the mean. And then for coefficient of variation, it tells you it's a CV, so coefficient of variation. Then we have our skewness, and we have our kurtosis. So the skewness and kurtosis, just as a reminder, are measures of dispersion. So it's asking, is the data skewed? So is it towards the left or towards the right? And kurtosis is saying, is it heavily peaked or really flat? So skewness is a measure of left to right, and kurtosis is a measure of peak. And we need normally distributed data for most of our analysis, so it's good to check skewness and kurtosis. Okay. And then we have, we have one more that's IQR, which is interquartile range. So it follows the same code patterns as before. The database name, which here's Ginzburg, quote marks is the variable name, which is depression, and then drop false. Drop false is going to say keep all of the variables in here. Keep them all in here. Keep all the value points in here. And then statistics, you run it if it's classified as an IQR. And IQR is the shortened interquartile range. So this is the first time I'll tell you something that I don't really love about Stata. About R. So I'm going to highlight this, hold down control and hit enter. And do you see how it gives a value So here it actually gives calculated range of the IQR. Almost all other statistical packages, when you ask for the IQR, it gives you the 25th percentile value, the 75th percentile, and the difference between the two. Because the IQR is the interquartile range. So it cuts off the upper 25% and the lower 25% and puts them into a range just like that. Pause here for a second and ask a question. If you wanted to know what the 25th and the 75th percentile value was, what code would you use? Like, and I don't mean literally type it, like, what code have we talked about that you could use? It's not num summary. You remember what it is? Yeah, quantile code. The quantile code would pull it in. To answer your question, is there somewhere you can look at the different statistics? Absolutely. You look at the help file, it'll tell you all of the statistics that it runs. So you just type in, and then whatever the thing is you're looking at. Yeah, George has it. Phenomenal. Of course he does. George is great, y'all. You should work with him. Okay, questions about any of this? Cool. Let's go on to multiple.
There was a question about the drop equals false. Could you cover that again, please?
Yeah, so drop false. Don't drop it if it's missing. The analysis on all of the database are all of the variables that are in the database. Okay. So if you want to run multiple, I'm just going to back this up so you can see it better. On a single variable with multiple statistics. So I do this a lot. Let's say that I want to look at my main dependent variable and I want to look at all of these different specific statistics for it. That's a common time that you'll say, I want one variable with multiple statistics. So how you run this is num summary and then the database name and then the name of the variable. So the database name is Ginsburg. The variable name is ADJ fatal. And then we see that drop false in here again. And then I say, I want to run the statistics under all of these different classifications. I want the mean, the standard deviation, the standard error of the mean, the IQR, the quantiles, the coefficient of variation, the skewness, the kurtosis, and the standard deviation. And then the quantiles that I want are these different ones. So I show you this because if you're anything like me, you want more than the summary statistics that R gives you as the default. You may want them in a specific order because you may have a table if you're putting in a publication or a presentation that needs specific statistics in it, so you can build your own. So I'm going to run this line 308 and 309 because that's all one set of code. And to pull it from one line to the next is there's a comma and the code isn't finished. Keep running until the code is finished. I'm going to hold down Control and hit Enter. And then down here, you'll see that it outputs all of those values. You'll also notice that it puts them in the order that you asked for them. So mean, standard deviation, standard error of the mean, IQR, CV, skewness, kurtosis. Now, you're probably saying to yourself, but there's an SD right here. You'll see how there's an SD right here and there's an SD right here. If you ask for the same statistics multiple times, it will not repeat it. It will just give it to you the first time you ask for it. And then at the very end, something that's nice is it gives you your N. So the N is going to be the valid responses for that variable. So 82 people answered the question about ADJ fatal or had a value for ADJ fatal. So that's for one variable. But you're probably a person who does research on multiple variables. So you want to see the relationship between mental health and overall happiness in life, or mental health and job success, or mental health and happiness, all these different factors. So if you want to run multiple variables and multiple statistics, that's line 313 here, you say num summary, the database name, and then you classify that by all of the different variables that you want to include. Now you'll notice that the variables are in quotes and there's a comma between them. The order in which the variables are put in the code is the order in which they will be produced in the output. So when you go to make your, most people call it their table 1, their descriptive statistics table, the order that you put the variables here will be the order that it is produced in. So if you want your variables in a specific order, this is your time to do that. And we have our drop false again. And then the statistics that we want are mean, standard deviation, quantiles, and coefficient of variation, with the quantiles classified as 0, 0.25, 0.5, 0.75, and 1. I'm going to highlight this, hold down Control and Enter. And you'll notice that it makes a pretty nice little table for us here in the console or the output. And you'll notice that ADJ fatal was first in our code, ADJ fatal is first in our table. So this is the time that I try to always say in workshops, do not rewrite code, just copy code and use it. So when you go to run your own, don't think that you have to memorize this. A couple of my colleagues and I were actually having a conversation about this in the last couple of weeks, like how much code do you have memorized versus how much code do you just know? And I found out that most of my colleagues, they don't memorize code, they just reuse code. So this is a super common practice. Don't be looking at this, especially if you've never coded before, never used R before, and be like, oh my gosh, there's no way I'm going to remember all this. Right, you're in really good company. That's how most people are. They just, reuse code from other sources. So hopefully this is a good source for you to use in the future. Okay, is there any questions about running specific statistics, multiple variables, or running multiple statistics? Y'all seem pretty good about just asking questions when they come up, so I'm going to keep going. All right. So so hey, Lion, if there are missing cases, it will show the smaller n, because remember when we pull in data earlier, we had that NA, so it will show up as NA, and NA is missing, so it would only tell you who doesn't have missing data. So if we were missing 15 out of the 82, it would reflect that in your N for your statistics. That's a great question. Okay, other questions, comments, or rude remarks? I'm going to keep talking because it bothers Catherine when it gets quiet. Okay, so the next thing that I wanted is thing. Now, I will tell y'all that this is the first in a 2-part series. In R2, we're going to cover a lot more statistics and cover like making variables and things like that. I just want to get you to know enough to be dangerous and practice a little bit between tonight and next week if you choose to come. So a lot of the rest of the time we're going to have is going to be dedicated to graphing. That's because graphing is tremendously better in R than almost any other package. So let's talk about graphs. So we're going to start with what looks like very complicated code. We're going to back into simple code so that you can see what R produces as a general output. So here's the code for scatterplot. The code is scatterplot, variable 1, variable 2, and then I'm going to come back to this section right here. So for right now, try to ignore it. And then you say this data, the database called Ginsburg. So this is a pretty simple code if you ignore this middle part. It's saying make a scatter plot for this variable by this variable using the database Ginsburg. So if you would please have, wow, I'm so used to doing this in real life. Okay, so I'm going to highlight this, hold down Control and hit Enter. And y'all will see in this bottom corner, the scatter plot produced. Now I want to give y'all a heads up because I know that some of y'all are overachievers and you're trying to like run this on your own computer at the same time. Some people's RStudio, based on which version you have, it will open in a new screen, and then some people it will open in the bottom right hand corner. It is the same. Okay, so we see here This is just a really basic boo-boo scatter plot. So when y'all make scatter plots, what is normally on there that is not here? Daisy, ggplot's a lot better, but I just don't cover it. But yeah, it's definitely better. What is something on a scatter plot that y'all normally have that isn't present on this scatter plot? A regression line, for sure. So we're going to add the regression line in. So scatter plot, this is where that middle section that we ignored, we're going to come back to. So this is how we add a regression line in. Scatter plot, ADJ simp, ADJ fatal. So just like, but here the regression line is now true. So regression line is now true, which we'll put in our regression line. Notice that smooth is still false and box plot is false. So we'll add those in later. It's easier to learn the code just as we add. So scatter plot of ADJ simp, ADJ fatal, add in the regression line, which is reg line, smooth false, box plot false, and then data Ginsburg. I'm going to highlight this, hold down Control and hit Enter, and y'all will see that it automatically populates a regression line on here for you. Now, I'm going to kind of talk about a couple other things that some people put in regression lines, but not necessarily. Some of us really like model fit lines. So beyond the traditional regression line, we add in model fit lines to really see what else is being produced and what are some other options that were tested for the fit of the overall plot. So we're going to add in model fit lines and keep our regression line for this next set of code. So scatter plot, ADJ simp, ADJ fatal. So make a scatter plot of ADJ simp and ADJ fatal, which is what we've done before. Reg line is true, which means put the regression line in. And then we want the smooth true. So smooth in graphs in R is model fit lines. Then we still want to keep our box plots false for now, and we're still base Ginsburg. So we highlight this and run it, and y'all see now that our model are also included on our scatter plot. The thing that you can add in is the box plots. So this last line of code has all of those functions. It has the regression line, the model fit line, and the box plot. I'm sure that you're kind of looking at this being like, wait, all of that stuff is missing. What's going on? So that whole section on like reg line, true, smooth, true, box plot, true is all missing. This is because in R assumes that everything is true unless you tell it false. This is a really important thing to learn. R assumes that everything is true unless you tell it false. So if everything is true here, we actually don't need to identify it because R will assume unless we say false, it will be true. So I'm going to run this scatter plot, ADJ simp, ADJ fatal, and those variables are in the database called Ginsburg. So let me run this, make this kind of big so we can. We'll notice that we have our original scatter plot with all the points. We have our scatter plot with the regression line, which is this solid line. Then we have model fit lines, which are dashed lines. And we have box plots. So these box plots will tell us for ADJ simp, this is the box plot. So we see we have these high-end outlier values. And then down here we have ADJ fatal, and we also have some outlier higher-end values. This is the default scatter plot in R. So the reason I don't show this when I first start teaching coding in R is because I did one time and people completely zoned out because this was the first graph they ever saw. And they were like, I don't know what all those lines mean. Why are there dots? I don't know what that box plot's doing. So the truth is the base code do everything. Now this is something that's a bit different than like Stata or SAS or SPSS. Those programs assume that you want a base model and then you do add-ons. R assumes that you want everything unless you tell it otherwise. So this is a really important thing to denote. All give you base information and then you add information in, but R gives you everything and then you remove things. So that's how to run a scatter plot. So you can, if you want everything to be produced, like the scatter plot in the bottom right-hand corner, you just use line 350. And it's very simple. Scatter plot, ADJ simp, ADJ fatal, data Ginsburg. And then, but if you want to remove different functions, that's when you start using these false statements. Remove the regression line, you make this equal to false. If you want to remove the model fit lines, you make smooth equal to false. And if you want to move the box plots, you say box plots are false. The default is true, and you just tell it when you need things to be false. The reason in my code I have these true statements is because I wanted you to be able to visually see what we were changing on the back, cause the changes on the front end. But if I remove this line of code where it's true, and I just delete that, it will produce the exact same output that if I leave reg line true. It assumes true unless told otherwise. That's a scatter plot. Just as a reminder, scatter plots should be used with two continuous variables. Your home discipline may call them interval ratio variables. Scatter plots are supposed to be, unless you have a really fancy exception, variables. Then the next graph that I want to show y'all is histograms. So histograms are pretty basic. You say, with the database Ginsburg, make a histogram on the variable depression. So the code is with database name, variable name. And you'll see that right here in the next line of code. I'm going to run line 360, so hold down Control and hit Enter. And I'm going to blow this up again so y'all can see it a little bit better. I know my screen's kind of small. See that it gives you the different options across the bottom, and the default is frequency. So the default measure is frequency. If you're from a home discipline, like if you're researcher, your home discipline reports percents, you can change this, and I'll show you how to do that. But just note that the default for histogram is a frequency. And then right here, you'll see that this is the same code. With Ginsburg, database Ginsburg, make a histogram on the variable depression, and then make the scale frequency. If I wanted to make the scale percent, I would use this word from frequency to percent. Or if you want to run it as density, if you're in one of those rare research groups that runs density for histograms, you would change this to density. So the scale, you just run it as frequency, percent, or density. Walk through, beyond this, some editing options. If you want to add a title, you just add this little bit of code on the end. So just as before, how it says with depression, we're going to have with Ginsburg histogram depression, and then a comma, and then main, which means main title. We're going to call it depression scale. So main is for the main title, depression scale. So I'm going to highlight this, hold down Control and hit Enter, and you'll see that it adds depression scale at the top. Now, you could also, if you want, call it like figure 2. So let's say that you're making different figures for a really basic report that you want to put out, and it will change the title very easily. Now, I also want you to know, call this garbage, and it will. So this is a point where you have to make sure that what you say you're measuring is what you're actually measuring. So whatever title you put in will. So that's how you add a title in. If you want to change the color of the bars, you just add a little bit of code on. You're picking up on a pattern that each time if you want to edit something or add something on, you add it towards the end, and it's an add-on. You do the main bulk of your coding, and then you do add-ons at the end. So to change the color of the bars, you'll say, with the database Ginsburg, run a histogram on the variable depression. We've done this over and over. We want to keep the scale as a frequency, and we want to make the color of the columns red. So I'm going to highlight this and then run it, and it will change it to whatever color you put in there. Now, to just say this out loud, there's about, I think there's like 10,000 colors in R. There's entire packages for colors. So if you are somebody who's really into aesthetics, you're going to love this. And later on, I think it's in this workshop or maybe the next workshop, I give links to packages and like kind of tutorials on how to do different colors. I do not care about this that much, so I'm not as well versed as people, but I will do my best to answer your questions if you have some about colors. Okay, then if you want to change the number of columns, this is how you do breaks. So breaks are going to be the number of breaks in the range of data. So if you look at this depression over here, you'll see that this right here is a break. This is a break. This is a break. This is a break. So in between each column is a break. So the default breaks are distributed relatively well in R, but if for some reason you want specific breaks in your data, you can do that. So changing the number of columns to one break, and an easy way to remember this is take the number of breaks and add one. That's how many columns you'll have. So one break makes 2 columns. So with the database Ginsberg, run a histogram on the variable depression. This time I'm changing the scale to 1%, just so you can see what that looks like. And then I'm going to make the breaks equal to 1. So I'm going to highlight this, hold down Control, and hit Enter. And y'all see how it went from all of those columns to just 2 columns. And then if you want to make it so that it's 10 breaks, you would just change the break number from 1 to 10. So I'm going to highlight Ryan 382, hold down Control and hit Enter. And y'all will see this is from before. So the default is 10 breaks for a histogram. And so it does that for you. And then if you, for some reason, want to do 100 breaks, you can also do that. You can do really an unlimited number. Hold down Control and hit Enter, and it breaks it up even more. So you're probably sitting there and being like, why would I ever do this? Like, why is this something that I'm interested in? So hear me out. I kind of feel like I live in multiple worlds. So like I work in the library, but I go to a lot of like sociology and statistics and health conferences. Based on who my audience is, will determine like kind of how many breaks that I use. Because in the library world, they like really, really basic numbers, really basic breakdowns of data. But when I go to a group of statisticians, they're going to want to know more of the distribution of data, and they're going to want to know a lot more nuances. So using the different number of breaks should be done for a reason. You can also, and I want to just say this out loud to make sure you don't do this, some people use the number of breaks to kind of distort their data and tell a different story than what's actually happening. So they may put in 100 breaks with 30 data points, and then the data looks very different than if you put in 4 breaks. So think about the purpose of what you're trying to do and be very careful about it. So that's histograms. And did y'all notice that this changed to percent over here? So it was a frequency, but now it's a percent. So you can change these vertical axes really simple. And I have notes in here. If you want it to be a frequency, you make the scale a frequency. And if you want it to be a percent, you change the scale to a percent. As a general rule, almost all graphical studio, you can use the scale option, and the scale option is an add-on. So if you want it to be density or frequency or percent, you just simply add this scale in. Okay, now that let me see if we have after. Okay, let's do one more and then I'll stop for questions. So the next graph that we're going to do is my favorite graph, which are, so for box plot, the code is box plot, and then you'll see this little tilde, and then the variable name, the data identified, and then ID list method Y, and you'll see that it has a Y and a none, so a yes and a no. If you say yes, it will identify the outlier. So let me run this really quick. You can see this. Okay. So this is our box plot for simplicity. And we have a box plot here. Just as a quick reminder, if you haven't used box plots or you haven't used them in a while, the bottom line is the lowest value, not accounting for outliers. The top line is the highest value, not accounting for outliers. And this middle box is the middle 50%. So this middle 50%, this is the 25th percentile is the bottom of the box, the 75th percentile is the top of the box, and then the middle line is the median or the 50th percentile. So then y'all will see that 77 here and a 65 here. I've gotten more than a handful of emails of people being like, I have these outliers and the values don't match because 77 is not between 2 and 2.5, and 65 is not between 2.5 and assuming 3. Do y'all have any idea of what these numbers mean? They mean something very specific. Do you know what these numbers mean? Yeah, those are the ID numbers. So if they had people's names in there, it could say Rada and George or Jeremy and Sally. So we have an ethical concern here. If we are going to be producing this box plot and putting it in any public forum or any way that other people could look at it other than our research team, we need to remove those identifiers. So by putting the numbers in there, it allows us as researchers to say, I need to go to case 65 and see if I should exclude them from my analysis, or see if there's something wrong with their datum points. And the same for person 70. So this is nice for us as researchers, but we should never, ever share that information with other people because we have ethical considerations for our research participants. So you'll notice that the difference between line 408 and line 413 is simply the Y and the none. So I'm going to run the none line, and you'll see it removes those for us. So now we can take those identifiers out, but we can still share a box plot and say, hey, we have 2 outliers, but now we're not saying who those outliers are. So this is something to really think about and just be cautious of. Please don't ever violate the trust you have with your respondents, and make sure that you remove those notations. Okay, so before we go into 3D scatter plots, do you all have any questions about scatter plots, histograms, or box plots that haven't been answered by my colleagues? Oh, sorry, I have to keep talking. Oh, okay, not clear why these specific ID numbers and not other ID numbers appear. Great question. So let me read. So I'm going to rerun line 408. And you see how this is a 65 and a 77? What that means is respondent 65 has an outlier value, and that's why it has a circle. So respondent 65 has a really high value on simplicity, and respondent 77 also has it above the normal acceptable range for simplicity. So it has a really high value. So the reason that their ID numbers came up is because they are the outliers. So if case 43 and 22 had outlier values, these would be 43 and 22. Now it is worth noting that sometimes you don't have outliers. So don't go run this on your own data and be like, oh my gosh, it's broken, I don't see any circles. That means that you don't have outliers. Maybe everybody fits within a normal distribution. Maybe you have really, really homogeneous data, and so you can just run your analysis from there. That was a good question. Exactly. So saying yes means the number or respondent number listed. Yeah. And instead of, let's say it wasn't a number and you had names, it would say Sally and Josephine here. Okay. Will we use another package to get the p-value of R-squared? You don't have to. You can get R-squared. Well, the R-squared infers that you ran analysis because R-squared is the amount of the dependent variable accounted for by the model. And the R-squared is going to be produced in the analyses that do that. So like next week, we're going to do regression, and it'll give you the R-squared values and the p-values. Just a little bit of a spoiler for you, Stephen. R doesn't just give you, it also tells you the number of stars. So you can just actually look for the stars, and anything that has a star is statistically significant. For that next week. Yeah, so that's a great question as well. Well, they're all good questions, but you know what I mean. So let's do scatter plot matrix. So these are my favorite things from the R1 workshop. And that's because I want to show y'all that with relatively simple steps, you can do cool stuff in R. So this is going to be some 3D modeling. And we're going to run a scatter plot 3D, which means I want to put 3 variables in my scatter plot of simplicity, depression, and fatalism. Now you'll notice that this part right here is the same as our scatter plot from before, but then when you add in your third variable, it is a plus sign. This is going to be your third dimension. And then you identify the database, so database Ginsburg, and we're going to say surface false. So I'm going to highlight this, hold down Control and hit Enter, and pull this scatter plot over, a 3D scatter plot over. So it comes really small like this, and I'm going to make mine full screen. And then all I'm doing is I'm clicking and I'm dragging, and you'll see that it's a 3D scatter plot. You can see the relationship between these 3 different variables of simplicity, fatalism, and depression. So we notice that there's a general positive relationship between them. As fatalism increases, so does simplicity and depression. And that's why it looks like it's kind of jumping out at us. And then if we look at it from the back end, we can see that it's exploding forward. So this is the most basic 3D scatter plot. Have a reason for doing these, but they're fun to play with. So that is a reason enough for me to do them. I'm going to close this out. The next thing I'm going to do, just like before when we had our scatter plot, is add a regression line in. So we're going to say run a scatter plot that's 3 on simplicity, depression, and fatalism. Use the database Ginsburg, but make the surface true means I want there a regression line. Now remember, this is 3 variables. A regression line, we're going to have a regression pane. So you'll see that we have this blue pane that exists between the 3 variables. Now y'all will notice that there are red lines and there are blue lines. Now these are our residuals. These are our error between our actual value and our predicted value. So the reason that they're color coded is because it's really easy to flip 3D upside down and not realize necessarily that you did it. So the red means that the value that you predicted is over the value that they had, and the blue means the value you predicted is below the value that they actually had. So just as a reminder, all of these little baby error terms added up are your residual. So all of these little lines added up would be our model residual that we get from our general linear models, so our ANOVAs, our regressions, and all of that. So blue means that you under-predicted, red means that you over-predicted. So an easy way that I remember this is if your bank account, it might look pink to y'all, but if your bank account's in the red, that means that you have less than what you should. So that's how I always remember what is red, what is blue. This seems like something that wouldn't come up that much, but it does quite a bit. I've actually seen somebody present their research and had this flipped upside down and not realized it. And they looked pretty silly, so don't be that person. Okay, so that's a 3D scatter plot. You can also add in an ellipsoid. So we're going to say run a 3D scatter plot variables on the database Ginsburg. So this hasn't changed. I turned the surface back off, so I removed that pane. And then I said I want to keep the, which are those error terms, the blue and red lines. I want the background to be white. So if you wanted the background to be fuchsia, that. I want the axis scales to be true, which means I want the scales on each of the axes. I want the grid to be true, which means I want you to identify where they are on the and then the ellipsoid to be true. So I want to add in a 50% concentration ellipsoid. So highlight this, hold down Control and hit Enter. I'm going to pull this over, and you'll see that it adds in our 50% ellipsoid. This is not a game of bingo, even though it looks like that to me every time I run it. What this is it's saying it's having an ellipsoid that contains 50% of the data. So you can look at kind of where the core of the data exists. So we see that it goes up and out, which means that there's probably a positive relationship between these three variables. We kind of saw this earlier, but this really encapsulates it for us a bit better. I'm going to close this out. And then if we want to add in, you remember earlier we had those wavy lines for our regression, those model fit lines. You can also do this with the 3D scatter plot. The 3D scatter plot, the thing that is different is, remember, the regression line is a pane. It's not a line. It's a kind of that flat blue grid. This smooth fit line will also be a wavy plane. So this 3D scatter plot on the variables simplicity, depression, and fatalism. Use the data from the database Ginsberg. I want the fit to be smooth. Now this, you'll remember this from earlier because you're really smart and because we did it. Smooth means I want the smooth fit lines, which are those model fit lines. This is the same term that was used in the scatter plot earlier. I want the residual terms to be noted. I want the background to be white. I want the axis scales to be labeled so they're true. I also want the grid, so between the three of them where the balls are placed, those datum points, to be true. And I'm turning that ellipsoid off. Fit line. I'm going to highlight this, hold down Control and hit Enter. And now you'll see that we have a model line in here. So these, again, just as a reminder, are those model fit lines that we had from our scatter plots earlier. The waves. So we had our solid line, which was our regression line. And then we have our model fit line, which is this wave. And you'll notice if you look closely, the ones below have this still red residual marker, and the one above have the blue residual marker. And this is truly for you to be able to visually depict above and what's below. Okay. Close this out. So this is our model fit, just model fit pane. So the reason that it's a pane is because it's three-dimensional, so it has to count for all three variables at one time. Now, if you're fancy and you want to do things like change the background color and things like that, I want to show you how to do that. The background is nested right in here where it says BG. Black. So if you wanted the background red, you would change this from black to red or blue or white, whatever you would want. So you'll notice we're just changing individual components of this scatter plot right now. So we addressed like model fit line, regression pane, ellipsoid, background color. All I'm doing is taking that core code and editing. So I'm going to run this. And I think that this is a little bit better if you want visual depth. You may disagree with me, and that's cool. Data visualization is not my forte. But you see here, we just have our datum points with a black background. So this is a nice little way to depict our data. I'm going to close this out. Y'all will notice that this is even called overload is easy in these models. So we're going to say I want a 3D scatter plot with simplicity and depression and fatalism from the database Ginsberg. I want smooth, so I want the model fit lines. I want surface to be true, which is the regression line. I want the residuals true, which error terms. I'm going to make background white, and I want the axis scales to be labeled. I want the grid to exist, and I want the ellipsoid. I want y'all to know that this is an example of don't do, okay? Somebody rolled into my office and met with me and whipped this out, and they were so impressed. And this is too much, you know, like somebody is going to look at this and they're not going to quite understand what you're trying to do here. I always like to ask somebody who is like really smart but knows nothing about my topic, about my graphs. And so from this, and I asked them, what is this? And they said it looked like a whale with like birds and fish swimming around it. Like they had no idea what this was actually measuring. So use wisely and make sure that it makes a lot of sense. If you're going to do a really, really complex graph, I would suggest maybe doing it in steps when you go to present it so people can understand what you're adding on. Okay, so I'm going to close this out. And then let's do bar charts and pie charts. Yeah, that's pretty much it. And then I have some practice questions at the end if we get to it. So for a bar chart, the code is with the database states. So this is different. It's with database name. Make a bar plot, variable region. Label the X region, label the Y frequency. Now notice that these are just labels. They're not changing what they are. So I could call this X label bananas and it would say bananas. But for a bar chart, you have to say what the labels will be. So I like to put the variable name for the X label and then whatever it's being measured as is the Y label. So let's run line 460. It generates this for us. Now I know that the default of a bar chart in R is a frequency. If you are from a discipline where most of your bar charts are in percents, then you would need to change this. And that's called changing the scale. So in R, it means how something is measured. So we're going to change it from a frequency to a percent here. So with the database states, make a bar plot on the variable region, make the X label region, the Y label percent. So this is basically the exact same as our code before, scale percent. So we're going to convert it from a frequency to a percent. Earlier I mentioned if you don't tell it goes with the defaults. So the default in R is frequency, and we're going to change it over to percent. So highlight this, hold down Control and hit Enter. And now we have percents. Now, some people would want to add, and we talked about titles earlier, but I want to make sure that we cover it again. So if you want to add a title, you say with the database states, make a bar plot of the variable region, make the X region, the Y label frequency, and then main. Remember, main is how you put a main title in, and we want it to be income. Now, the problem with let me keep going. And then the scale is frequency. So these things that are after the comma, they can go in any order. So you could say scale frequency and then main income, or main income then scale frequency. So I'm going to highlight this and then hold down Control and hit Enter, and it adds income as the title. So you can make the title whatever you want and talk about it from there. That's how you add a title in for a bar chart. So if you want a basic bar chart, it's just with the database states, run a bar plot on the variable region, label the X axis region and label the Y axis frequency. And then you can change the scale if you would like. You can also add a main title if you would like. As a reminder, if you haven't bar charted recently, use these with either nominal, ordinal, or interval variables. You should use a histogram for a continuous variable. You'll notice that there's little baby gaps between the bars. That means that we know that there is a difference. And if they are ranked, we know there's a rank, but we don't know the exact difference between each column. So it should be used for nominal, ordinal, and interval variables. And then the last thing that we're going to do is a pie chart. So pie charts are going to be used with nominal variables, or ideally never, because I don't like them, but here we go. We're going to say, with the database states, make a pie chart and table it in R. Table means break it down by. So make a pie chart, break it down by the variable region. and then label the levels, which are the different by the variable region. So I'm going to walk through this one more again. With the database states, and then table it, and remember table means to break down by different groups, the variable region. And label the different sections, which are called levels, by the variable region. So the different categories within region. I'm going to highlight this, hold down Control and hit Enter. Makes this pie chart. Now, I mentioned earlier that R is really great for graphing and people really like it. Pie charts are not its jam. I don't know why the default is like bad Easter pastels, but here we are. I'm going to show you a couple of different things that you can do, including how to change the color. But that's the basic code for a pie chart. If you want to add a title in, you use the exact same code as before, but you add in this main. You've noticed that we've used main for histograms and bar charts and pie charts. They're pretty universal. So with the database states, run a pie chart, break it down or table it by the variable region. Label the different sections, which are called levels, by the variable region. And then make a title, that's the main title, called region of the US. Let me highlight this, hold down Control and hit Enter, and it adds in region of the US. And then if you would like, there's a gap in this code. I'm just going to delete it so that it's easier to read. If you want to change the color, you can do that down here. So this code is the same, label the levels region, and then I want to change colors and classify them as light blue, blue, dark blue, and cyan. So these are different shades of blue. And then I want to make the border white. So right here, y'all will see that this line is black. So we want to make that white. So we're only giving it 4 colors: light blue, blue, dark blue, and cyan. So I'm going to highlight these 2 lines of code. And remember that column, that comma will pull it to the second line and it'll finish the code out for us. So I'm going to hold down Control and hit Enter. And then it puts these colors in for us. Now you'll notice that ENC and WSC have the same color. And that's because we gave it 4 colors and there are 9 options here. So what it's done is it's duplicated that color next to each other. So if you want to make them all different colors, you can. The order in which you put the colors is the order in which the generated at. So it starts right here and it goes light blue, blue, dark blue, cyan. Light blue, blue, dark blue, cyan. Light blue. So as it twirls around, it changes the order. So this one is the first, ENC is the first, and it goes ENC, ESC, MA, MTN, NE, PAC, SA, WNC, and then WSC. So you would want to have at least 5 so you don't have these touching each other. Okay. I also, just as an aside, I would strongly suggest that you give it a different color per group, because people will read this and think MTN and WNC are the same thing or they're connected in some way. So make sure that when you make these pie charts, you do different things. If you are a person who needs to publish this in a journal that doesn't, for some reason, do color, there are shades of gray in R. So we're going to say, with the database states, make a pie chart, table it, which means break down by region. Then the labels or the levels, which are the different slices, will be from the variable region. Make the color as gray 50, gray 70, gray 90, gray 100, and then make the border gray 1. So the lower the gray. So gray 1 is black and gray 100 is white. So y'all will see this on the output. See how it says border gray 1 and those borders are black. So I've always wanted, and I'm sure somebody's done it, for someone to make something in R use shades of gray and then like building it into something about data visualization, but I digress. There's 100 shades of gray that you can use. Given that I actually know some of y'all who are in the workshop, and I know that you have like really amazing, I feel like you may use this next section. This is an entire color palette that has been generated for R that you can look at. And the library is called Color Space. And then these are a bunch of different colors that you can pick from. So I'm going to open up one of these so y'all can see it. That website didn't work. So when you download a package and you look up the package, this is what it'll look like. They're usually LaTeX documents, but I want y'all to see there's all of these different, look at all these versions of antique white. Like, what are we doing? So you can have tons of different colors if you want, and there's pages and pages of colors. So these are all those I'm telling y'all about. Here's grays. And you can see that their gradients are a bit different. And as the number gets higher, the gray gets lighter. And there's tons and tons of different colors here. The reason I show you all this is not because I am a really good at transparency as well. It's not because I'm really good at graphics in R, but because it's a draw of people to R. So if you're working maybe as a program evaluator or working with community-based research and you really want to use specific colors of that relate to the population or make it really helpful for people, let's say you're studying older adults and they may have macular degeneration. So greens and blues are good colors for older adults, but maybe for different populations, rich reds would be really good colors. So I want to wrap up the last couple of minutes to tell you all about a couple things. And then Jeremy, would you do me a giant favor and paste in the check-in for everybody? I think y'all already did it, but if you could do it again. There's these practice questions at the end. These practice questions will walk you through different things that we have done today. So if you would like to practice and then come to R2, or if you just want to practice in general, I have all of these questions built in here. The questions get more challenging as you go through the section. One is not harder than question 2. So like question 1 set is not harder than question 2, but down they get harder. So this is the easiest, and then this is the more advanced section. So the reason that I suggest I want to tell you all about these is I've noticed that people who practice a little bit between workshops seem to really grasp the data and grasp the program a lot better. And if you work through the code and you hit a snag and you want to know what the answers are, you can email me and I'll send it back to you. Please do me a favor and don't feel rude. Send it with high importance. I get a lot of emails, but if I get something with high importance, I'll check it. So if you want to practice this code and do that, you can. Okay, if you would click that link that Jeremy posted in the chat and check in. This is how we're going to do the data certificates. But even if you don't plan on getting the data certificate, if you could please check in, because our dean likes to know how many people come to the workshops. So does our department chair. And then I am going to be quiet just for a little bit so y'all can ask about anything that we've covered tonight. But I want to thank you for coming, and let me know if you have any questions. I'm going to put my email in the chat really quick. Does anybody, you're welcome, Elian. Fun fact, Elian is my old office mate and she's phenomenal. Do you have any questions? So Felix, if you will check in on that link, it'll give you an email saying that you attended the workshop. And if you attend 5 different workshops or watch 5 different workshops, you get a free data certificate that will email to you at the end of April. Y'all are very nice. Does anybody have any questions? There's nothing outside of the library certification. You do get an email confirming that you came. And if you need to, like, take the class for their boss to like prove professional development. So what I ask that you do is email me and say, "Dear Dr. Anderson, I attended your workshop. Could you please verify that?" And then I'll email you back. And that's the closest thing to like a formal paperwork that you would get. But we don't do certifications just for one. The recorded lectures will be posted on the website that Jeremy and George keep posting. And it takes about 12 to 14 hours to convert it. So it'll probably be put up in the next couple of days. But it won't be instantaneous. But the recorded lectures will be up through April 20th at 8 a.m. So we're taking them down on April 20th at 8 a.m. All of the workshops will be repeated this summer, but the dates aren't out yet. Thanks, Michelle. That's really nice for you to say. Yeah, you can download the recording once it's uploaded to that website that Jeremy and George have posted a couple of times. I'm gonna see if I have that. How would you show attendance for the workshops that you watched on the website? Is that what you're asking? Oh, you get in, at the very end, there will be a link to check in just like today. And if you go to 5, you'll get the certificate. So like if you wanted to, like on some Saturday, binge watch workshops, which is something I may have done this last weekend, you can do that. So there's the link for checking into the workshop. Jeremy, do you have the link for the website that we're putting all of these on, please? For sure. I'm glad it was helpful. Okay, cool. Thanks. So give us a couple of days to get the presentation uploaded because it takes a really long time to get them up. Yeah, Felix, I'm actually surprised at how many people reach out to me on LinkedIn and ask me if I want a job. So I'm approached by headhunters for like coding gigs, probably like once a month or every other month. But I've noticed that a lot of job postings have a desire for R. And I work with some people at the Department of Energy, and they're actually all converting over to R. And so a lot of government agencies are as well. So I personally think it's one of the most marketable skills or marketable programs, I guess. Okay, gentle people, if there's any more questions, let me know. If not, we're going to close this out. Felix, are you at Georgia State? Oh, cool. You have access to LinkedIn Learning, and LinkedIn Learning used to be lynda.com, and Georgia State pays for you to have access. So if you just go and search for LinkedIn Learning from the GSU homepage, you should be access to it, and there's tons of really great certifications on there. I'm gonna type in LinkedIn. Yeah, for sure. I've done a couple. I actually learned a little by LinkedIn Learning, so I like it. It's similar to what we're doing, only you can't ask people questions. If you're not Georgia State, you can also, but I think that it's not free. Okay. Anything else before we turn off the recording? And just as a reminder, R2 is same time, same place. All right, gentle people, I think we have exhausted questions. So thank you. I'm gonna close everything out. You'll stop the recording and then we can move on.